Okay, given information. The original position is given as 0 meters, and there's an original velocity of 5 meters per second. And it's positive, which means it's going to be going to the right. It has a constant acceleration, we're told, due to a fan. Now, the direction to the right is positive. Okay, the cart reaches a maximum position of 12.5 meters. Where it begins to travel in the negative direction. So that means it's at rest, because that's when it starts to travel in the negative direction. So I'm going to state that the final velocity is 0. And that's going to occur on my diagram right here. So the fan is causing a thrust on the cart to the left. Okay, and for now I'm just going to call it F subscript T for thrust. We're going to be studying force in the next unit when we get to Newton's laws. But that's what's causing the cart to accelerate, and that's what we're trying to find. So we go to the kinematics equation and look for an equation that involves the unknown and as much of the given information as possible. So we do have an equation, Vf squared is equal to Vo squared, where O is for original, F is for final, plus twice the acceleration times the displacement. And we know the displacement, it's xf minus xo. Okay, here's xf, right? And xo is 0 meters, and that's the beginning of the story. So continuing, let's solve this for acceleration. So we have Vf squared minus Vo squared divided by 2 delta x. Where delta x is xf minus x original. Okay, substituting, Vf is 0. Square that, you still get 0. Vo is 5 meters per second. We need to square that. Divided by 2 times xf is 12.5 meters. And xo is 0 meters. Okay, so let's, I just plugged in the values, and now let's figure out the answer. Plug and chug. I'm going to do the denominator first, so 12.5 times 2, and I'm going to divide that into 5 squared. Well, the denominator turns out to be 1, and the numerator, the denominator turns out to be 25, and the numerator turns out to be 25. So what I end up with is 1, and there's a negative sign there, so it's negative 1 meters per second squared. Negative 1 meters per second squared is the acceleration. Okay, here's a nifty demonstration of the problem I just solved. Okay, we have the fan cart here. It's blowing air this way, so the thrust force is going to be to my right, to your left. So here we go. I'm going to give it an original velocity. So the story, let's say, starts right here where I'm pointing. That's where the story begins, when it would have the original velocity given in the problem. Okay, and you notice where it stopped, right about there. Okay, so that would be the end of the story, where the final velocity is 0. Right there. What I would like to do next is draw the corresponding motion graphs for this fan cart. So the fan cart starts out with an original velocity in the positive direction. And at the end of the story, it's at rest. And since it's a constant acceleration, I have a straight line at an angle. Remember, the slope of this gives us the acceleration. And you notice it's a negative slope, and it's a constant slope. So we would have a constant negative acceleration. Okay, so there's the corresponding acceleration versus time graph. Now, the position versus time graph would have to be parabolic. The cart starts out with an original velocity, which is in the positive direction, and then it comes to rest at the end of the story. Okay, now I'm going to draw a vertical dot line showing where the end of the story is exactly for each graph. And there you go.